Welcome back to part 3 of our Python tutorial. Last time we looked at string methods, and this time we're going to look at list methods. So I've gone ahead and just made a third notebook file and made a list called myList with just a few integers inside of it. So let's dive in. So we've now ran this line of code that has my list defined, so now I can access it in a new line. And let's start seeing things that we can do with my list. Well, we could clear it if we want to, so that would just empty out the whole entire thing. We can append, that's one we'll be using a lot. So let's say I wanted to put 1000 into my list, then I can append. Now, here's the first thing that makes lists far different from strings. If I now look at my list has been changed forever now, essentially. So the list was defined with these 5 numbers. I appended 1000 to it, and now 1000 is in that list for good. If you remember last time when we looked at string methods, the string methods, I guess you could say, temporarily or instantaneously changed the string just for that moment, and you need to capture that in a new variable or reassign your variable in order to keep that change. Otherwise, you still have the same original string. But that's not true with lists. Lists change on some of these methods forever unless you undo that change. And that's why we call lists mutable and strings immutable. So a string is never changed. It's always preserved. You can modify it and again store it in a new variable, but you still have that old string somewhere sitting in your memory. And then at the same time, we can do the same, we can do modifications to lists, but they are preserved, so they are mutated and therefore mutable. Okay, so we've appended to a list. What else can we do? Well, again, just take a look around. We can count occurrences just like before, so we can count how many 75s there are. Well, there's 1. That's not too interesting. Let's make it interesting by just clicking run on this append 1000 cell a few times. Now we can see there's more than one 1000. So we can count the occurrences of 1000, and we now know that there are 4. Cool. We'll just look at a few more of these because, again, it's really more so about just knowing that you can click on any one of these and look through the documentation or Google, hey, what does the insert function do for lists? Well, the insert function says give me an index. So let's say I want the 3rd index where currently that 75 is. And at the 3rd index, I want to insert some sort of object. And let's just make it really obvious and put a Boolean true in there so that we can really see that it's different. Now, if I look at my list again, you can see that the Boolean true is now in the 3rd index, in the 75, and everything else got pushed over to the right, so to speak. Cool. Maybe just one more, or really 2 more. We'll talk about the pop. Now, pop says that it removes and returns an item at an index, and the default is the last. So we can see that if I run pop, it removes and returns. That's why we see the 1000 there at the bottom, but it removed the last 1000. Now there are only 3 of them. Now you can also provide an index. So let's say I wanted to get rid of the 98. Well, that's at the 2nd index, so I can pop 2. There's the 98 popped, and now 98's out of my list. So we can append and we can pop. Now, the one last thing we might want to look at, I think sort's probably pretty obvious, is I want to look at the copy, because what we did, or what we have been doing, is we've been modifying this list. But let's say we wanted to essentially take an original list and see what happens when stuff gets added or changed, but we still want access to that original list. We want to know what it was before it was changed. Well, that's what the copy can do for you. So let's just say second list. Let's make a second list, and let's say that list is just 1, 2, 3, 4. So I've got a new list. It's a second list. And let's now say I want the 3rd list to be equal to the second list dot copy. All right. So now I've got a copy of the second list, and I can see that by running my 3rd list. And now what I can do is I can say, okay, let's append, I don't know, 2000 a few times. And if I now look at my second list, I can still see that my second list only has the 1, 2, 3, 4. And if I look at my third list, I now have the 2000s that I ran a few times. So the copy method allows you to keep that original list and then essentially have a copy of that list where you can change it, modify it, whatever, but you still know what the original was in your code somewhere. And why is that important? Well, let's restart this terminal. Let me restart. And I'm going to just, after it finishes restarting, I'll clear the outputs as well. I'm going to make second list. And now let's see what happens if I don't put this copy in there. If I don't put the copy in there and I say the third list is equal to the second list, look at what happens if I run append to the third list a few times. There it is, 2000 appended a few times. But let's look back at my second list. My second list actually has those 2000s appended as well. So if you didn't really know about the copy method and you tried to, do what we explained a few minutes ago to your list, you might be pretty confused to say, whoa, why is my second list getting all the changes that are being applied to my third list? Didn't I essentially make a copy of it right here? Technically, no, and it's a really deep concept that we don't have to go into, but more so just something to be aware of, that for lists, and it's kind of special in this way for lists, because it is mutable, when you say, I want third list this variable to be equal to second list, what you're actually doing is you're actually saying, hey, I really just want this list to be known by 2 names. You're not actually saying, I want a new list that is the same as my second list. You're really saying, I want 2 names that go to the same place. And that's something that happens with mutable objects with variable names sometimes. So just be really cautious with that. And let me even check myself, because a dictionary, and that's what we're going into next, is another mutable type. So let's see if dictionaries have that same behavior. I've never actually, tested that out, but let's see. So let's go to the stereotypical, let's say we had 7 apples, and let's say we had 3 pears. I think that's what we did last time. I've got my dictionary. And let's say now that other dictionary, whoops, needs the underscore there. Other dictionary equals my dictionary. And we'll dive into some dictionary methods, but let's first just test out our theory about mutable objects. So let's say I wanted to do other dictionary and I wanted to add something to it. I could say other dictionary lemons, and let's say there are 7 of them. So this is how we add new key value pairs to dictionaries. There we go, it's been added. Now dictionaries are mutable because, hey, I just changed it, and let's see what my dictionary now looks like. Hey, same idea. Dictionaries are mutable objects as well, and so if you try to make a copy, so to speak, of a dictionary, you encounter that same behavior unless does it have a copy method? Yep, it sure does. So there you go. If you see a copy method, know that just calling it by another variable means you now just essentially have, your regular name and a nickname that you can also go by, and you are changing the same dictionary. Okay, so once again, I'm going to kind of restart and clear outputs, and we'll get away from that kind of hairy subject. Don't worry about it too much, but maybe, just know in the back of your head, if something ever goes wonky, if you feel like your list is changing when you didn't want it to somehow, maybe you accidentally, called this list that you were caring about by another name, and you're really modifying it in 2 places, and you don't think you are. So it's really just kind of a caution, not something we don't encounter it that much. Okay, anyways, let's learn about dictionaries more so. So we've got my dictionary, and we've already seen that we can add items to it. So let me, cut that out and just put it up there. And, not other dictionary anymore. It's my dictionary. Okay, so we can add new key value pairs to a dictionary. What else can we do? Well, again, let's just press the dot and see what we can get. So we can see the keys. So that is a function. Let's put the keys in there. And we can see all of the keys in our dictionary. So In other words, if you want to know, hey, what are the names I can pass in like this to get a value out? Well, I can either pass in apple, pears, or lemons. And let's see what happens if I put in apples. And again, you get that nice auto typing to already know that that's one of the keys, but you get 7. Well, what if you wanted to know just the values by themselves? You can also do that as well. You can get the values. If you wanted to know the items, that's really just a way of saying, hey, please give me all of the items in the dictionary, which seems like it might not be that useful, but we'll actually make a lot of use cases out of this later. If you want a way to iterate through the key value pairs of your dictionary, that would be the way to do it. So we can see the keys, we can see the items, we can see the values. We can also pop in the same way. So let's say I wanted to pop lemons, because lemons was the one I added in. Well, just like list popping, dictionary popping spits out the value. It returns that value. But also, again, if we now look at my dictionary, lemons and its value 7 is gone. Cool. All right, maybe one more. Really, I guess update is one that we can call, but you probably wouldn't call update in that way. What we can do is we can say, okay, there were 7 apples, but let's say we get a new shipment in of apples. And let's say, okay, now I don't have 7 apples, I have 30 apples. So now I want apples to be 30, and I've just done that. I've reassigned the value for the apple key. It's now 30, the 7 is gone. So that makes a lot of sense for, doing inventory. You're going to get shipments of apples. People are going to buy apples. You're going to be adding to this and taking away from it. Now, speaking of which, you're probably going to be adding and taking away from. You're probably not just going to be saying suddenly, oh, this is 30. You would probably say, oh, we got 23 more apples. So how can we do something like that? Well, we could say I want, for instance, my dictionary pairs to be equal to my dictionary pairs plus 40. So let's say we got a shipment of 40 pairs. So I now know I got 40 pairs. I need to add it to the old amount of pairs I had. That would be the way to do that kind of through code. And there we go. We now have 43 pairs. Now Python has actually a way cooler way of doing this. You can actually just do plus equals 40. So this is a shorthand way of saying you actually don't need to say, hey, my dictionary pairs equals my dictionary pairs plus the other thing. You can actually just say, I want to plus equals. In other words, I want to add to the last result this amount. So if I run this now, I had 43, so I should now have 83, and I do. So the plus equals can be really handy. You can also do minus equals. So let's say that someone wants 100 pairs. Well, then I guess now you are 17 pairs in debt, if that's a thing you can be. So you can plus equals, you can minus equals. That's a quick way of reassigning a value, and we'll do this a lot in our code. You'll find yourself doing plus equals 1 a lot, and we'll show you why later. Okay, I think that's about all the methods we need to look at for a dictionary. But hey, we should revisit one more thing about lists now that we've seen this. We've been updating key value pairs that have already been defined. And hey, this is a mutable object. Do lists have this same property as well? Yes, they do. It just kind of didn't seem natural to do that with lists so far, but it is something you'll come across. So what you can also do is you could just say, hey, I want to know, again, by indexing, what is in the second index of my list? Well, it's 98. Well, what if I now know that I need the second index to be 5,000? All right, well then I can reassign that value. I can say my list 2 is no longer 98. My list 2, or my list, the item in my list at the index 2 is no longer 98. It now needs to be 5,000. Let me check my list. There we go. You could also do that kind of plus equaling. So let's say I want the first, or let's test this one, the last item of my list to have 200 more than it previously did. So it was 23. And I just plus equaled 200, so now that should be 223. So we can do the same thing with lists. You can reassign or update the values inside of a list, just like you can reassign or update the values. And that, think about it, it is the same word, key value pair. In a dictionary, you know, the key is the literal key. And in a list, the key is the index. They're kind of behaving in the same way if you want to think about it like that. This one just doesn't have an explicit key. It's just known by its index. And this one is specifically known by its key, and it actually does not have an index. So that's the last thing to kind of say before we wrap up this video, is that lists are completely dependent on their index to get items out of it. They are ordered, and the order you type them in totally matters. So when you grab things off their index, that's the only way to grab them. And when you look at a list, it is ordered. Now, dictionaries, on the other hand, are not ordered at all, and I can prove that to you by saying, what if I want my dictionary at the index 2? Well, first of all, there is nothing at the index of 2 because there's only 2 items in there, so we could at most go up to index 1. But you can see that we get key errors because dictionaries aren't known by indexes because they do not have any. This is unordered. Even though we have to type it in some order to create the dictionary object, there's not actually an order to these items after they've been created. You just grab them off their keys. And that's the only way, again, we know how to get items out of dictionaries. So you need to pass in a key to get the value that you want. All right. Maybe the one last one we'll look at, because we've looked at lists, we've looked at dictionaries. Maybe we can look at tuples, because we haven't really created a tuple yet other than at the very beginning. So we could say my tuple is equal to, and you can either make tuples by, let's see here, true, false, 5, why not? Typing it in their parentheses, like how we've kind of made all the others. We've typed them out in their correct syntax, so with either the curly braces and colons and commas in between our key value pairs. In dictionaries, just a brackets, yeah, no, braces, whatever these are. I'm gonna call them square brackets with a comma in between for lists. And tuples are a little bit special because you could also define tuples without even putting any parentheses there. That's really kind of special. And I'll show you where you might have accidentally made tuples before without realizing it, but hey, there it is, true, false, and 5. Well, what can you do with tuples? Well, we did mention very early on that tuples are immutable. So the only thing you can do is you can get the count of the amount of items of like trues there are. Well, there's only one true in there, but maybe you've got a tuple that has multiple true values in there, so you could count those. There's one. Or you can get the index of something. So let's say you wanted to know where is the false, because tuples are also ordered like lists. Well, false is in the first index because we start from 0 and then we get 1. So that's all you can do with the tuple because they are immutable like strings. They feel different because they have that kind of they almost feel exactly like a list. It's just a list. Really, it is a list, but you can't change or assign or update any of the values. The only way you can change, update, or assign any of the values is if you rerun, like if you say my tuple equals this, then that's now locked and preserved. I guess what you could do is you could then say my tuple equals something completely different, like 9, 8, 8, 7, 4. Great. You technically have not reassigned a tuple or changed the tuple. You've said the variable name my tuple is now just pointing to a completely different tuple. So you're changing essentially what the variable is pointing to, but you are not changing the actual tuple itself. You're just recreating a new one and putting it in an old name you came up with before. Hopefully that kind of makes sense and you get what I'm saying there, that you're not actually changing the true to be 9 and the false to be 8. You're just saying, hey, whatever I used to put in this variable name, trash it and now put this tuple instead. That's not modifying the tuple, it's modifying your variable's name and like where it's pointing to. All right. With that being said, the one last place you might have been accidentally making tuples early on if you did some experimenting is maybe you said like my large value equals 1 million. So let's say for some reason you wanted to hold on to 1 million and you ran this cell. You might be really surprised to look at my large value and then see this pop up. because that is definitely not 1 million. What you just did was accidentally make a tuple, and you made a tuple because remember what we did up here, we said you can type in tuples without those parentheses. So when Python reads this, it doesn't read, 1000, like how we kind of write it like humans. We put commas every 3 place values. Python reads this as, you want a tuple with the value 1, 3 zeros, well, that's just mathematically equal to 0, and 3 zeros, that's mathematically equal to 0. It thinks you're separating items in a tuple when you write it like this, because the space doesn't need to be there when you define that tuple like we did here, but we had the parentheses. So one little note there, again, that you might have caught yourself on. And these rules will make more sense the more you use them. And honestly, that's why I don't even try to make a tuple without the parentheses. It's just something to kind of show you, hey, you can do it. But I feel like it's nice to know why you might get that error. Well, hey, because tuples can be made without parentheses necessary, and you just separate items by a comma. Well, then this is a tuple. But really, I would probably just define it with those parentheses. I think that covers it for this video. We covered a lot. Again, feel free to experiment, and hopefully the idea of mutable and immutable makes sense. And I'll see you in the next one.